In this video, we're going to look at another example of analytical geometry. And so we've got a triangle ABC. We've been given A and B's coordinates. They've showed us where alpha and theta is, and there's an x-intercept happening at an E. And so let's dive into the question and see if there's any funkiness happening. Calculate the gradient of AB. So that's pretty standard, just making sure that I'm subbing in brackets the change in y over the change in x, and that gives us positive 15 over 9, which simplifies to an answer of 5 over 3. Determine the coordinates of E, and so because that was an x-intercept, we're going to have to first work out the equation of this line. And so for 4.2, it's going to be y equals 5 over 3x plus c. I know I'm missing a letter, and so I'm going to sub in a point. I'll sub in b because it looks a bit easier to me. And so when I sub that in, y will be 12, x will be 4, and when I take that across, I get a c value of 20 over 3, so it will be 12 minus 20 over 3, which is 16 over 3. And now if I want to get the x-intercept, I just let y equals 0. So I'm going to let y equal 0. I'm going to take the 16 over 3 across, and I'm going to divide that by 5 over 3, and that gives you your final answer for your x of minus 16 over 5. That's your x-intercept value, but they wanted the coordinates. So to finish off properly, I write it as a coordinate, and that would be your answer. Determine the size of A, round off to the nearest whole number. Sometimes we forget these little extra nuances that they give us. And so A, whenever you need an angle, you're just going to work with this formula. Tan theta equals m. Do I know the gradient of the line that touches it? Yes. That was the 5 over 3. So tan theta equals 5 over 3. And if you ever need an angle, you're going to press shift. And then just to be fastidious, I'm going to change this formula to tan A, because I've got thetas and A's, and I don't want to get confused later. So when I shifted, I got an answer of exactly 59.04, but they wanted it to the nearest whole number, so that would be 59. Last question, so this is now 59. If theta is 76, work out the equation of a line going through A that's parallel to BC. And so two things are standing out for me. If I can work out the gradient of BC, then it will be the same as this gradient, and then I just need to sub in a point. And so what I'm going to do to get this gradient, and why might they have hinted at a new angle, is if I do sum of triangles, I end up working out that this is 45 degrees. And so the angle that it makes with the positive x-axis, which is what you want, is 135. And so again, because I'm working with angles, I'm going to go tan theta equals m. I know that the angle that it makes with the positive x-axis is 135. And when I punch that in my calculator, I get minus 1. So the gradient of this line is minus 1, which means the gradient, because it's parallel, of this line going through A is also minus 1. And so I can start y equals minus 1x plus c. I need to sub in a point, and I'm going to sub in the A value because it's going through A. I don't have a choice to sub in something else. And when I sub that in, I get minus 3 equals minus 1x, carefully in brackets. That's positive 5. So when I minus it, it becomes minus 8. And so my equation will be y equals minus 1x, or minus x, minus 8. I hope that you found that video helpful. If you did, please like it, subscribe to our channel, and share this with your friends.